Okay, so everybody welcome to CodeChef Lunchtime. Right. It will start in a second. We are in D1. We'll try to solve like several problems. Okay. And a second now. And a second. I don't know actually why we're opening last problems. In D1 it should be pretty hard. But what's up? Yeah. Even game CPP, we can copy sample input straight away. TXT. And integers in array A, two players take turns alternatively by placing signs plus and minus between them. And then they are all added, okay? Sign passed before any element was raised, it has not been assigned yet, okay? Player 1 wins, assume is even, else player 2 wins, find out who shall win if they both play optimally. Wait, does sign actually changes the parity? It does not change the parity. What the? Okay, so like their actions are irrelevant apparently because no matter what the sign is, you will end up with the same parity, right? Did I actually open D1? I'm not sure. Being extra careful, you know. We can say accumulate. Actually, you know what? We can compute it by hand, right? If S and 1, we can see out 2, 1. Who wins 1? If sum is even, wins 1. Okay. Oh, right. We should just output if this then 1, else 2, right? This is the expected way to do it, such things. Actually, we should see 2, 1, 2, I believe. And did it run because, right. Once, okay. Is it intended to be like that easy? I'm not sure that maybe I terribly misunderstood the problem. Or maybe just that easy. Hey, hello? Oh, so it's still running. How can that simple problem running for that long? Anyways, no, I don't want to wait for it to complete. Okay, so it's accepted. Dreams of divisibility. You know what? Lunchtime is actually easier than kick off, apparently. Every night, Mara dreams of divisibility problems, and one such dream Mara is given an array A of length n and number k. He performs many operations he wants to this range, and he wants to make every element divisible by k. In one operation, Mara selects two indices, and he does ai plus equals aj. If he can make everything divisible by k eventually, choose n in his dream. But wait, like, consider the last element that got divisible by k. No, like, we simply want to check that everything is divisible by k straight away, because if any element is, like, otherwise we can consider whatever element turned out, like, got divisible by n by k latest, right? Like, why did it get divisible by k latest? Because it was added something to it. But like, if something was added, then like that number is not divisible at the moment. So it's not the last one that turned in. Being extra careful for no good reason. Where is it? Okay. There was something starting with D, probably. We should see yes and no, which is not a particularly great case. Wait, actually, they said that in the first case he can. Right, because he can add number to itself. I did not realize. Yes, that's a good observation. Now, if he can add number to itself, he can just repeatedly add number to itself, no? He can repeatedly add unless, okay. Well, oof, okay. In the second case, he wants everything to get divisible by 6. He can't do it. Wait, actually. Who is n and who is k? M? K, 6. We can't make it divisible through any sequence of moves. And because when we add number to itself, we multiply it by 2. Oh, okay, so that's actually interesting. Oh, I actually know the person who proposed this problem. Interesting. So the last integers that get divisible by k should be like, this idea still applies, it's just different. Like, we know that the last operations that we did must be multiplied, like add number to itself. So ai gets ai, it gets 2ai, right? And then gets divisible by k. So if k is even, like if k is odd, then there is nothing to talk about. Okay, so if not all, then k is odd, then we can output null, I believe. I'm almost, yeah, I'm confident in that. I will definitely forget about that part. So Well, it's going to fix that case, I believe, or not, or is not. No, okay. So in the first case, you actually can make it divisible. Can make everything divisible by 2. Okay. Wait, but if k is even, if k is the power of 2, then we can do it like anytime we want, right? If k is the power of 2, then we can just repeatedly multiply every number by 2. The interesting part is like, what if actually anything different happens? Can I please get this? Okay, just curious, maybe somebody already solved it so that we know where to go. Maybe we are trying to, no, okay, so that everyone solved this. And it should be done in linear time, apparently, because like this constraint hardly allows any logarithm in it, given time limit of 1 second. Maybe sometimes other integers are of some help. Maybe it has something to do with GCD. Like, let's actually think. If number is relatively prime, and the only way we can, no, okay. What is the next problem? I just want to know that we are not so mechanism. In a good cell set to be good, if the value in the cell is maximum in column row, even n and x, determine whether this n by n grid is exactly x good cells. Maximum column and minimum in row. I think I actually know how to do it. Because like, look, we have the test kits, right? Yeah, that number series is good. We will definitely come back to it later. I just not now. Okay. Cell is maximum in its column and minimum in its row. And we can have repeated elements, so it's not like strict maximum. Okay, yeah, okay. Just not stop. So for n equals 1, answer like yes, okay. So 1, this is okay. I'm going to make exactly 1 here. Okay, like if we can always have one max element, one such element, right? So like in this case, max in a row, oh, they say maximum column. Okay, maximum column is always on the down side. The minimum in row is always on that side. So yeah, that's it. Suppose that we actually start with that kind of board, or like everything is okay, and then suppose, so we want what? Just to stay consistent. We want max, want min. Like, suppose that I change this to 9. Right? Then both of these two become good, right? They're both max in column and min in row. Suppose I change both of them to 5. These three become max in column and min in row. Suppose I now change everything to 1. So I can clearly have like if x is less than or equal to n, the answer is positive. What next? Next, I want another integer to become max in its column and min in its row. Well, I can clearly stack, like I can clearly say like, okay, let's make all of this, right? So if x is less than or equal to n, or x modulo n, if or x is divisible by n, right? Then answer is positive. Why can't I think I can't have like fractional number of these guys, but why? Like suppose I have a value in a column, in two different columns. I have such values in two different columns, right? But it's I have such value in two different columns. These columns are not complete. So here's like this number, okay? Which is wrong. Like this is not either, it's not minimum in the row or not maximum in the column. Then what does it mean that it's not maximum? Like it's not maximum in its column, so this is bigger than this, right? But then it's not minimum, or it's either not maximum or not minimum. Okay, so either this or this. But then not necessarily both of them. So what if we have something like that, right? Well, we actually, no, because we have, okay. Suppose that we have at least n plus 1, right? Then we have two entries in the same row, which means they are basically both minimum, okay? Suppose something here is out of place. Why is it out of place? Like it's either greater than that or smaller than that. But suppose that this is in place, right? But then how is it possible? Like these two guys are equal. Or wait, is it this one of them, right? One of these things is true. So if, for example, we have 0, 0, 0, 0, here, and then let's say 1 here. This has to be maximum, right? This has to be maximum. So if this number is good, this number is good, this is good. This is not good, right? Then this is maximum. So we always have like this kind of inequality. Then these are equal. But suppose like if he's not maximum, then he's strictly smaller than that, right? Suppose that here number is correct, then these two are equal. But he is like either not a maximum or not a minimum. But because this is a minimum, we also have such chain of events. So we always have like this kind of square. Right, so whenever we have like, if I add thing here, this will also become correct because like this, if 3 vertices are like good numbers, then 4th vertex of this thing is also a good number. We always have a sub-rectangle, right? In particular, we always have a composite number. And it's possible, like, can we have that thing? They have to be what? I constantly forgot. I keep forgetting. Like they have to be max in column, right? So everything in their column should be smaller. But then they have to be minimum in their row. Everything here we can just make it bigger. But then like we don't want this to become as they're not max in their column, so it does not matter. And here we just want to fill something random in, right? What if we just fill 1, 1? Like, look, this fails because it's not a minimum in their column, in their row, right? Now, this fails because they're not the max in their row, their column, right? And we remain with that thing. And we already checked that, okay, so what we want to do is we want to check that x is a product of 2 numbers, each of them is less than or equal to n. We can just do it in the product time, right? In mt time, right? If x modulo I equals 0, int y equals x over I if 1 less than or equal to y and y. I believe we don't have to check first constraint, but whatever. Bool found equals false. And not found, we don't want to run any extra steps. Found equals true. There was something with G, right? That's why people name like problems with letters, because it's convenient types. We should see yes, no, yes, and I definitely messed up the case here. Should be. Excuse me. Yes, no, yes. Okay, I'm pretty confident in that solution because it's kind of mess. And it works in n times t times, so we should be good to go. We can remove that. No, you know what? You know what? I'm not doing that mistake again. Yeah, let's be extra safe about that, because earlier today we had stupid problems about that. I'm definitely not exceeding the number of requests. This is the correct code. Yeah, I should have solved it faster not to have issues with the queue. You know the joke. Hello, can you let me in? Okay, you know what's like, we obviously can keep complaining, and at the same time we can just keep going, right? You know, like copying samples. I actually need to implement a tool to download the samples, because I believe like this kind of major computations, they follow the same format, input format. Right? So I should. Why? CodeForces has 30,000 participants, and it does not have such a problem. Why do you have? Pretty confident you have like a lot of money with all that educational initiatives of yours, so it should not be a problem, right? I mean, you teach people, yeah, I think you teach them for money, not for free, so you should have money for that kind of thing. What goes on here? Okay, I will just do what I can do all the time, anytime, read the info. Still running. Understandable, have a good time submission. What goes on? Choose three integers satisfying some conditions. Actually, these conditions I have to pay attention. So I have n piles of spoons. Initially, ice pile contains spoons. That's really not convenient that I don't have like notification for it. Shift X spoons from pile P to pile Q. That's it. Add X to subtract. Okay. So we can transfer any number of spoons, obviously present in both. No, wait. Not from anything to anything. From smaller to greater. From smaller piles to greater piles. Oh, that's interesting. I can't. I'm not 100% sure that this is correct. Like I'm almost sure, but you know, I would like to see the results. We can think about this problem here. So what do we have here? Here we have several files. Actually, I would like to see the So here we have a pile of 4, 3, 5, one smaller, less than or equal to 2n operations, right? Is this correct? It must, yes. Okay. What you can do, if there's a smaller number, you can transfer it completely. Excuse me? If there is a smaller number, we just can transfer it completely. So we transfer small numbers and then we check like whether it's the smallest number in the set or not. What? What? Pardon? Is it? You sure that you wanted to say like, hey, no. I have to read. How long can one submission take? I don't regret anything. I knew perfectly what I'm up to. So we can transfer from smaller part. Can I see my, okay, so I actually submitted twice and then it forgot about it, right? So, or I should not have closed this one. This is outdated. Okay, anyways. We want to print npx, number of operations. Okay. The total number, okay, so there are no stupid overflows. Okay. No, that one. Yeah, because I want indices. What am I thinking? Okay. Back into it. You know, I sometimes do this just to, like, just to get off whatever is in my mind and just get back to working as expected. So, vector tuple int 64T, I believe. Okay. PQX. So, if rest empty, why 2n and not n? Is it like just not giving away the idea? That's silly. Yeah, no, I'm actually, that's understandable completely. Yeah, I agree with these guys. You don't like this is just too easy. So the problem is that we have to move spoons from the smaller pile to the larger pile, right? Because of that, like if anywhere during our operations, first is value, then is index. So rest begin. If value is less than or equal to first, then we are very well welcome to in place into ops, in place back this time because it's a vector, not a set. And one based indices. Okay. Oh, well, indices are one based. Okay. Right. Absolutely. From two, right? From two. So it should be index one and then just value. And here we can actually request array ways. Okay. Else break. So the first letter is S for that problem because of the spoons. Okay. Excuse me. Right, because we are not adding center first. First. Can I please submit? Thank you. Did I click? Did you get my click? Not a lot. Perfect. Oh, actually, that was a bad idea. Like, what if that was the wrong submission and it resubmitted? Because of that. I want to make sure that I don't have wrong submissions for that problem. Oh, please let me. Thank you. I hope this actually logs. It does not look like it's that easy, but it just sounds that easy. I don't know. Okay, no submissions. It did not get. And then I can access the page. We'll get to it. We'll get to it. Okay. Okay, you know what? In such cases, we always can read the next problem. At least create the CPP file for it and also this is like IOI style, right? To get the points. if you solve some test cases. So we should investigate that as well. But I really want to submit that problem. Can I please submit that problem? Like, I would be okay if submissions just passed, you know, and then like you would respond in half an hour. That's much nicer than just getting, okay, so we managed to submit this. This is difficult, this is just contest status, okay. Okay, this is a submission. Okay. Heavy cars and runs in both petrol and diesel. Okay. The price of petrol and diesel is per unit volume or PP and PD respectively. Unit volume fuel, you can travel 1 unit distance, no matter CP units. Okay, so we have different capacities for diesel and petrol. Okay. And cities in M and directional, unidirectional. Okay, so directed graph. And points and lengths of the all the cities are of 4 types: no fuel available, only petrol. Okay, only diesel and both. Okay. The impossible cost of fuel you will have to buy. Well, that's interesting. Wow. So this is not correct for some reason. Well, at least we got like 1 wrong submission and not like 100 wrong submissions, right? Will it like be like for at least for test cases, just how wrong we are? Or there's like no additional information? I'm so, oh, whoa, so everything is wrong answer. Now let's read carefully. That should be P not equals to Q. We have n piles of spoons numbered 1 through n. I's pile contains AI spoons. In a single operation, we can do the following. Choose 3 integers p, q, x, satisfying 1 small less than or equal to p and q, and less than or equal to n. P is not equal to q. 1 is less than or equal to x, less than or equal to ap, less than or equal to aq. Shift x points from pile p to pile q. So we shift from smaller to bigger. Right. I'm so stupid. Okay. Whoa. Okay. So sometimes when our list element, when value is less, when value is bigger than first, makes sense to transfer something from value somewhere further up the road so that we can deal with it later. Where does it make sense to transfer it? Let's think about it. I would say that it makes sense to transfer to the max. Or does it? If we were able to take this plus I, we will be able to, okay. Okay. If rest, let us actually produce a test case when it fails. So that's why to n operations, absolutely. Cool. So we want a test case when it makes sense to shift from current place to later so that we can actually do anything. Let's grab ourselves 5 files. So this 2 will have to move further, but then we'll be able to add 1 here. We'll have 2 here and 3 here. Well, we don't want 3 here. Let's say we have 3 here, right? Or even like 4 and 7. 7. So you see, what we're going to do is we're going to shift, wait. Right, what we're going to do first is we're going to shift this one from second pile to the last pile. Then we do that, then we do that, then we do that, then we do that. But with our first approach, we would stop just here, whereas we in fact can transfer. It makes sense to transfer to the last one because suppose that you transfer to some previously, and it works, and to max does not work, right? Why? Oh, actually, I'm not sure anymore. Suppose we shifted something to some position. So we had like A, B, C. Suppose we shifted to this. Like this does not work, but this works. For this to work, A should be greater than or equal to B plus X. So this works, but this does not work. But if A is greater than or equal to B plus X, then this also works. So we can take, and then we want A plus B be greater than C plus X, and that may fail. Whereas this A plus B plus X greater than or equals to C works. What happens if we just shift to the next one? So we need another test case when a shifting to the last does not work, but shifting to the, wow. But shifting here works. Okay, suppose we have like 1, still we have 1. That should be 4, right? We have 4. 1 to shifting to the last does not work. Why? Because it becomes too big, basically. So last should be like really big. So like this, if we do it like this, what is going to happen is we're going to shift here, but then we will unite, and it does not work for us. What if we actually have something like here? If we shift, suppose we shift to the last one, right? It becomes something like this. Then we can unite 4, 0, 3, 6. And then we can unite. This will fail. So, for example, this was 7 already, right? 8, 8. So this does not work because then we have nothing to do. But suppose we shift to this one. Then we can unite. And we can unite. Then we can unite again. So 2 more test cases for us. Hopefully this makes our algorithm. So if we don't have that thing, we already unpacked these values. Then we erase. We say, if value is less than or equal to first, and we can just increment first the value. Otherwise, if rest is not empty, we want to add to the minimum of it. Because then we will transfer from minimum if we don't need it anymore, right? If we put something extra in minimum, we can transfer it to later stages. If rest is not empty, then value goes here. And we have to erase again because we will soon change the value. Ops in place back. From index, we shift to index. And what do we shift? In 64, p shifts equals value minus first. So this is it. Actually, there. Okay. In place index. No, first should be shift plus value underscore. It should be index. We put back that element. If rest is empty, then we failed. We failed. But we'll have to have like goal possible. True. And here we failed because there's nowhere else to postpone. So if not failed, if possible, right? If possible. And we'll print this, and we'll print this. Transfer to next. We now we also like took out. Yeah. Now what should happen is we should in place index 1, but not this, but this. So in this first plus equals. We can at most double, right? So this is what going to remain here. Assert. I agree. Yes, for that case, actually, where are our test cases? Spoons. It's for that test case, we output 7 operations. First, they say take 1 from second to third. I absolutely agree with you. Then it says take 1 from 2 to 1. Good. And it says take 1 from 3 to 4. So this approach is like a bit slower, but it definitely works. And it says take 2 from 3 to 1. And it says take 1 from here to here. It says like do this, and then it says do this. Okay. And for this, it says like from 2 to 3. So we start with that operation. Then take for here. We can even make it a bit bigger. That's just make sure that it works. Kind of. One of the last operations to change, and apparently this is the case. Oh, I did not save the file, but it somehow worked. Interesting. I'm not exactly sure that shifting to next smallest is optimal, but I guess it is in the following sense. Like we shift because we will then be able to like remove from it, right? We will then able to shift further if it's ever possible. And like annoying thing is that now I have to check that I did not make a submission, because if I did, then I don't want to make another wrong submission. And I did. Because I want to keep penalty as low as possible, like not to make. Okay, so there. Okay, so result will be shown here. I think actually now it makes most sense to work on this problem. Dreams of divisibility. We should solve it like in linear time plus possibly a GCD, right? That's what GCD, like why it's not like 10 to the 7. Or it's also like input size bounded. So yeah, like an extra GCD is fine. An extra log that is not memory log is fine. Here we can make it work because 3 multiplied by 2 gets divisible by 2. So we can effectively remove all powers of 2 from k, right? Because then we'll be just able to, on its own, to multiply everything. What if actually like this version works? While k modulo 2 equals 0. What takes so long? Oh, I know. Because no, not because of that. Huh? Well, k is always even, so now it does not matter. So now we should actually like output this. to avoid any inconveniences. Well, k divisible by 2, we divided by 2. There should not be any problems. I don't understand. It looks like an infinite loop or something. No, let's think again. Where is our input for diff txt? So k is this number. While it's divisible by 2, we divide it by 2. Or actually, like, we can do just that. Oh, okay, so we solved this problem. Cool. It actually means like we like one of 20 people who solved it already. Not bad. Somebody already solved. Anyway, okay, that's crazy. Can put it here. It just prints nothing. Why? I asked you to do a very simple task. Or it actually printed something. Oh man, I'm stupid. That's why you need a command line testing tool. Yes, no are correct answering, but this not. Yeah, I think like suppose you divide everything by 2, then multiplication by 2 operation does not matter, so they won't save you. Yes, I think this is what Kimi wanted to say. Kimi is cool, like that idea is not trivial. I mean, it's very nice. No, okay, it's not difficult. We just did not like that problems, so we skip like some problems further. But then again, like somewhere around here, we have subtasks. So we definitely will try to solve some of the subtasks. We have 1 hour submission one. Yeah, actually, if you're, in case you're interested, like this is a really cool album, or I don't know how do you call it, but it was suggested by E. Morgan somewhere in Discord servers. So he's like a grandmaster in Code Forces, and he listens to like pretty damn awesome music. So in case you're interested, I'll put the link down in the description. You can't hear it because like I'm listening in headphones. But in case you're interested, I'll definitely put it because I think it's great music, and whoever made it deserves to be worldwide famous. Okay. The only downside of listening to music from YouTube is that I get notified of comments under my videos. You know, drawbacks of being popular. Oh, I don't think we are actually that popular, but it's just something to keep in mind. Okay, so curve D. Nice. I mean, showing submissions definitely does not make my. Oh, so it's still running. Okay. What goes on in that problem? Can I please? Thank you. First line will contain number of test cases. That's something I'm familiar with. A second line will contain two integers and an m, obviously number of vertices. The second, well, okay, so that's the correct answer. And if we refresh the stem, we may get the idea of what problem of the remaining two is the most more difficult, what is less difficult. Okay. And soon we'll get this problem as well. So definitely should turn off these notifications. For 4 hours should be enough for the contest to finish. Okay, what we were saying. We have a graph problem, and what's the second problem that we have? I just want to make sure that like the last problem is not simple math. Yes, it is still lagging pretty badly. Because like we submitted at least fourth problem we submitted like 10 minutes ago. Okay, random grouping. There are n students. Their teacher wants to group them. The teacher is a fan of randomness and uses the following. Let G denotes the current number of groups. Actually, we don't need that anymore. But what we need instead. X group. Yes. Yes. I also want to open the test case in case I will have to modify it. Well, that's tricks and like X group, X group, X group. Well, that's all right. Okay. What is what this is? No subtask for us, right? Oh, actually, like one simple subtask. Okay. But what is the problem? There are n students numbered 1 to n. Teacher wants to group them. Randomness. G denotes the current number of groups. First, the teacher makes one group containing student 1. So initially, G equals 1. Now, for each student I to n, from 2 to n in this order, with probability 1 over J plus 1, he creates a new group containing this probability G is one of the group in random. And that, so basically, like, next student gets student into. I think you can model the same process with the following way. Like at random, you choose parent from 1 to n, actually, from 1 to I for the vertex I. If I is its own parent, then it goes to its own group. No, it's not the same, right? Yes, it's not the same function. Expected value of sum of squares of the group sizes. The answer should be modulo, okay? I don't think it's F15. It's not F15. Expected number is like always about some DP, right? And mass, DP and mass. So we are actually not, oh, but there's, okay, so input consists of one simple, but not one to do that. Now we have something to do. But actually, yeah, let's, what goes on in the graph problem? Will it refresh anytime soon? I really want to know what's the sample one used. Okay, so it's not number of test cases, number of cities and routes. Second line contains string plus CPCD, PD, PP, PD. The fourth line contains separate types. Okay. Paranoid, you know, by the time. Then we have routes, right? Correct. I'm trying to like imagine how it is going to work, but it's hard. Um, Most probably will need the reverse well. I kind of want to do a DP on reverse graph. What is L? So the routes have plans, man. It's not complicated. It's not complicated. Things are just so ideally we would like some like DP in Dijkstra order or something like that. But it won't be in distance, it will be in cost. So some DP slash Dijkstra on that graph. In place. Yeah, music is good, but it's distracting. When you want to focus, it's better not to listen to music. Here we want to actually do something. Man, okay, like what is the problem with DP? It may be optional to like buy diesel in this city, right? Then you want to find out what is optimal in the previous city. And says, I would like to buy some diesel too. But finds that you're like capacity is too high. And we clearly can't do DP with CPCD included, because CPCD is up to 300. We want to include both of them. It's just an absolute disaster. In price lens, we don't care about price lens. Price lens can be whatever they want to be. CPCD, we care a lot, and I mean a lot. Because like currently the size of our DP is n CPCD, which is 300 to the cube, which may actually pass if you forget the number of roads that you have to travel, right? But if you don't forget to keep it in mind, you clearly see that like no Dijkstra, no log overhead, not even close. You can't afford it. Or actually, no, the number of transitions I think I can't solve like for these constraints and for this also. And 2 seconds look a bit more promising than 1 second. Oh, my head is not working the way it should. This looks tempting, like I would love to solve this problem. Wow, okay, so this seems to be more updated than this because it still does not show. Okay. Wow, so it's a cast. Oh. I mean, we should keep going because it's like hard. First. What are all these people? How are we even here? How are we even here, even midway the contest? Imagine it finishes now, right now, right? Will remain above all these people unless they solve something else. And something else looks like partial points. And that's what I don't actually like. They may be able to get past. Yeah, I need a break because it's just too much for me. So basically, while I was eating, I figured out how to solve this case. Simple GP. I'll do just that right now. Need modular inverse in module, like fast exponentiation, basically. We simply don't need anything else. The idea is as follows. Start dp is a vector of size m. dp at 1 equals 1. So it's an exact. No, it should have been. Okay. Can we afford it? 1 million times 8 bytes, 8 megabytes. Yes, we can. So I believe initialization is with 0. So it would be 0 at 1 is 1. We're interested in, I know it's necessary, but take the next person. We loop through all possible number of groups. We can have I groups. Two things can happen. This probability, like exactly as described, it's probability 1 over g plus 1. Next person will get into the new group. So dp and g plus 1 at index I plus equals dp at I minus 1. What is the first index? First index is the number of people processed. Okay. G, but then you have, okay, we all, yeah. It's okay. Well, I actually already started working on my modular integer class. Just did not have enough time to complete the work. By the way, it means that we can say like this. Num equals mul for modular multiplication, obviously. This thing I'm going to fix by hand. So if this is bigger than mod, mul that's the probability. Also, I still multiply by the same thing. Yeah, definitely. You see, like, why I don't want to do that. But you also want to multiply by g. No, let's actually do it the good way, because otherwise I will definitely forget something somewhere. You know how it goes. By the way, eating can be a really good distraction when you want to switch your mind off and on again. Just in case you're on. So I have only like 2 transitions per layer. No, we have G transitions there, so that's quadratic. Second integer represents number of groups. Or actually, yes. Wrong. Add, what's add? Most probably dp adds n minus 1, let's say g multiplied by g. That looks exactly as unexpected value, right? That. Line 43 is incorrect. Line 43, yes. Actually, add returns void. Import must return value, I agree. Oh, because it's not in, it's txt. I don't know why I was. This is incorrect. Ready? Oh, we want sum of squares. For whatever reason. Yeah, you know, probably for that reason it just sounds so funny. Wow. I agree. This is not what we expected. Was it the first sample zone? Okay. So something is broken. Interesting. We initialize with 0. After that, each thing stores a probability. Should we just print dp at n-1g to get the feeling of roughly how much off we are? I can't say that it's particularly helpful, but let's see. We are expected to get 1/2 and 1/2 actually. Wait, wow. Okay, I'm just stupid. I found expected number of groups instead of finding expected sum of squares of sizes. That's disappointing. I need to consult with standings. These standings are obviously off. Some people start solving group PD. And contest is long from being finished. Interesting. Should I just... I wish I solved these problems slower so that I could not think about it. I don't know, it's just... I'm a bit mentally exhausted. I can do really well, right? If I solve last time. Okay. Okay. What is the cheapest way to get to the origin, to the finishing point? Trying to figure out what DP should store. What is the cheapest way to get to the end point if we have that much petrol and that much diesel in our car? Something like that is expected from us. Capacity. Capacity diesel plus 1. Initial value is 0 by default. That syntax enlightened is strange. Probably nobody ever writes vector into production cut. Maybe, well, vector int, I don't think so. I think a lot of people use it, but vector might be a problem. I don't know, we are not like that. Nice. This matches, right? Matches up perfectly. Should do 1, 2, 1, 2, 3, 2, 1, 2, 3, 1, 2, 3. We have our digs. Oh, it's so complicated. I just don't want to sing. Oh. I don't know, people, I'm tired. I know it's not good to walk away from the contest, but this just sounds too complicated, so I don't know. I don't want to justify what I'm about to do. But I mean, I think it's more than enough for you guys in the video. And I'm sort of tired. So yeah, please, I hope you're understanding. That's it for today's video. I just don't want to solve the problems. I was not expecting to be where I am now, and I feel a bit scared of these problems. I will just spend a lot of time not solving them in the end. I don't know. That's it for today.